Chapter 15, think and explain. Number 47, which is greater, increase in temperature of 1 Celsius degree or 1 Fahrenheit degree or 1 centigrade degree instead of Celsius. Not going to let that die. Keep it alive. And don't forget, the U.S. customary units for mass were slugs, and let's not let that one die either. So if you think about the freezing and boiling point of water, it's 0 to 100 on the Celsius scale and 32 to 212 on the Fahrenheit scale. Those have to cover the exact same amount of actual temperature change. So because I have a lot more of the Fahrenheits are not as great. They're smaller. From an economics point of view, I've got more Fahrenheit than I have Celsius, so Fahrenheit are not worth as much. You could also think of it like inches and centimeters. The fact that a meter is 100 centimeters, but 39 and change inches. The inch, there's fewer inches. The inches are worth more, so an inch covers more ground than a centimeter does. So 47, the answer is that 1 degree Celsius change is greater than 1 degree Fahrenheit change. 48, in a glass of water at room temperature, do all the molecules have the same speed? No. Temperature is related to the average kinetic energy, so the 1/2 mv squared. So first off, a glass of water has other things other than H2O in it. It's not pure water. There are other things in it which allows that, basically allows electricity to flow through it. If it were just plain water, if it were actually pure water, then the electricity would not conduct through it particularly well. Just a side note. So they don't also have the same speed, but on average there is a particular value, and that basically is it. Number 60, which is likely to have a greater specific heat capacity, an object that cools quickly or an object with the same mass that cools more slowly. If it cools more slowly, that means you have to take more energy out of it in order for it to change, and therefore the object that cools quickly is going to be the one with the lower specific heat. So once you have them cooled, so if I start them cooled and I bring them out, the one with the higher specific heat will take longer to warm up, and so that will stay cold longer. Relating back to the think and rank number 43, where aluminum has a higher specific heat, so it will take longer to heat up. It will stay cool longer. Number 62, why does a piece of watermelon stay cool longer than a sandwich when they're both removed from the picnic cooler on a hot day? Because water has a relatively high specific heat compared to a lot of other materials or substances, and so watermelon has a lot of water in it. It's even in the name, and so just that water keeps the temperature from changing drastically. 71, citing an exception to the claim that all substances expand when heated. Water. You take water, put it in the freezer, it will expand as it gets colder. And matter of fact, and thank you for the indulgence here. If I can grab here it is. All right, sorry about the delay there. There are actually, I've got a list of 7 materials that expand when frozen. And sorry about the ding there. Let's see if I can turn that volume off. That silicon will expand upon freezing, gallium, germanium, antimony, bismuth, acetic acid, and water. Those are the substances that I have a list. Probably got it from Wikipedia, but not necessarily. But those are materials that expand upon freezing. So there are 7 exceptions. Number 79. In terms of thermal expansion, why is it important that the key and lock be made of the same or similar materials? Because locks are exposed to the elements. We have outside locks, such as to outside door as well as to cars, and as things heat up or cool down, it is going to increase or contract. And one of the ways that keys work is they have to fit perfectly. So if I've got a lock like this and it fits perfectly, if this expands, if it expands too much, the key is not necessarily going to be able to match the teeth of the key, are not going to match the pins in the lock, and therefore it won't work. Or if the lock shrinks and the key doesn't, then you might not be able to fit the key in. So they definitely have to be the same materials. 85, why do large steam pipes often have one or more relatively large U-shaped pipes? So let's just imagine that I'm connecting these two sections right here. And so I have a pipe that stretches just straight up. There are no U-turns in it. What would happen as it expands, as it heats up, it'll expand and it'll start pushing on the edges here, which potentially will cause a rupture, or it will shrink and fall off. And so when we're talking about U-shape, so basically we allow some bends in here so that the expansion doesn't push on the edges as much, and it's going to basically expand on the parts that are sort of winding around like that. Those parts will expand, and so it allows expansion in other areas without actually destroying the pipes. And especially if it's fixed on the ends, it'll sort of force the expansion in the middle sections. So that is I believe it's Think and Explain. Think and Explain for Chapter 15.